In 1977, you could walk into a hi-fi shop and carry out a cassette deck that weighed 26 pounds, ran 3 separate heads, and pulled tape through a dual capstan system so precise it made reel-to-reel owners nervous. The compact cassette was never supposed to sound good. It was invented for dictation. A handful of companies decided to fight the format's own physics and win. The gear they built still works. Some of it came from places you would never expect. In 1963, Philips invented the compact cassette, and it was not built for music. The tape was narrow. The speed was painfully slow, just 1 7/8 inches per second, roughly a quarter of what a decent reel-to-reel ran. It was designed for businessmen dictating letters, not for anyone who cared about fidelity. Audiophiles treated it as a joke, and honestly, they had every reason to. Then, the counterattack began. Dolby B noise reduction arrived and cut the hiss. DuPont developed chromium dioxide tape and pushed the usable frequency range higher. And a new generation of engineers, mostly Japanese and European, asked a question that should not have had a good answer. Can you extract audiophile performance from a format that was physically designed to be mediocre? The battlefield was the head. A standard 2-head deck uses 1 head for both recording and playback, which is a compromise that limits both. A 3-head deck separates the jobs, letting each head be optimized for its single purpose and giving you real-time off-tape monitoring so you hear exactly what the tape actually captured. Add a dual capstan transport, 2 pinch points pulling the tape instead of 1, and the flutter practically disappears. These companies took something designed to be cheap and disposable and engineered it into something extraordinary. That is the exact opposite of what happens today, where manufacturers take perfectly capable technology and deliberately hold it back so they can sell you the upgrade 18 months later. The 5 machines on this list are the proof that it used to work the other way around. If you care about what real engineering looks like, stick around. Number 5. The Advent 201. This is not the biggest machine on the list. It is not the heaviest or the most expensive. But without it, nothing else on this countdown exists. Henry Kloss had already co-founded KLH and Acoustic Research before he started Advent with a radical idea. Make the compact cassette a serious high-fidelity format. His first attempt, the Model 200, used a Nakamichi-built transport and proved the concept but stumbled mechanically. So in 1971, Kloss replaced it with the 201, dropped in a bulletproof Wallensack transport, added Dolby B noise reduction and chromium dioxide tape support, and quietly changed the entire industry. Look at the thing, and you would never guess. 2 heads, 1 VU meter. A modest, top-loading walnut cabinet that looks more like a piece of furniture than a weapon. But this was the machine that forced every major manufacturer to take cassette seriously as a music format. Before the 201, cassette was a toy. After it, the arms race began. And here is the detail that tells you everything about how differently companies used to think. Kloss printed the full schematic diagram on the bottom of the chassis so any competent technician could service it without begging the factory for permission or paying for a proprietary manual. Try finding that attitude anywhere in consumer electronics today. The Advent 201 was never the most powerful deck on any shelf. It was the one that proved the concept, that a format everyone had written off could be made legitimate with honest engineering. The logo said nothing. The thinking inside said everything. If the Advent proved cassette could sound good, the next machine asked a very different question. What if you could build a head so hard it essentially never wore out? Number 4. The AKAI GXC-760D. While every other manufacturer was building heads out of permalloy, a nickel-iron alloy that sounded decent but wore down steadily with every hour of use, AKAI went somewhere nobody could follow. The company developed what it called GX heads, glass and crystal ferrite, a design where the core was cast inside glass to create a surface so hard that AKAI guaranteed it for 150,000 hours of continuous use. That is over 17 years of non-stop, around-the-clock playback without replacement. Let that number sit for a second. The GXC-760D was the machine that brought this technology together with everything else that mattered. 3 heads, 3 motors, a dual capstan closed-loop transport, and AKAI's proprietary ADR system, automatic distortion reduction, which adjusted recording equalization on the fly to squeeze performance out of whatever tape you fed it. The recording and playback head gaps were machined to such tight tolerances that the time delay during simultaneous monitoring was barely 1/10 of a second. Open one up today and you understand immediately why restoring these is a serious commitment. The circuit boards are packed so densely they look almost hostile, and there is no silkscreen printed on them, which means every single capacitor position has to be verified by hand against the service manual. This was not built for easy maintenance. It was built for performance at any cost. AKAI asked a question nobody else was asking. What if the most expensive component in a cassette deck simply never needed replacing? The answer was a head that has now outlived the company that made it by decades. The machines keep running because the part that touches the tape was designed never to quit. AKAI solved the longevity problem. But the next machine took dead aim at the most sacred name in the entire category and said plainly, "We can match them for half the price." Number 3. The Pioneer CT-F1000. Pioneer launched this deck with one of the most aggressive ad campaigns in audio history. The print ads said it plainly. You can buy a Nakamichi 1000 Mark II and get an incredibly expensive cassette deck, or you can buy a CT-F1000. The Nakamichi cost around $1,650. The Pioneer was $600. And Pioneer was not bluffing. The CT-F1000 was a 3-head dual capstan deck built around single crystal ferrite heads, not grains of ferrite pressed together like everyone else used, but heads cut from a single crystal for maximum electromagnetic precision. It carried dual Dolby circuits, one dedicated to recording and one to playback, so you could monitor a Dolby decoded signal in real time while the tape was still rolling. Add pitch control, a built-in 400 Hz test tone oscillator for proper calibration, and a pair of fluorescent VU meters that still look stunning nearly 50 years later, and you have a machine that left almost nothing on the table. The whole thing weighed over 26 pounds and was machined to EIA rack mount standards, meaning you could bolt it into a professional equipment rack right alongside studio gear. This was Pioneer doing what it always did best, taking flagship technology and making it accessible to people who could not write a blank check. The CT-F1000 did not match the Nakamichi in every last measurable parameter, but it got close enough that the difference stopped mattering to anyone outside a laboratory. Same lesson the realistic STA-2000 taught in the receiver world. The prestige tax is real. Pioneer proved that the gap between a deck costing $1,650 and a deck costing $600 was not a $1,000 gap in actual performance. It was largely a gap in branding, exclusivity, and the comfortable margin a company can charge when nobody dares to challenge it publicly. Pioneer dared. But the next machine on this list came from somewhere even more unlikely, a small factory in Norway that had no business competing with the Japanese giants and competed anyway. Number 2, the Tandberg TCD 330. Tandberg was a Norwegian company headquartered in Oslo. It was tiny by Japanese standards. No global distribution empire, no billion-unit supply chain, no army of ad agencies pushing its name into every magazine on the newsstand. What it had was an obsessive focus on tape transport engineering and a complete refusal to cut a single corner. The TCD 330 was Tandberg's flagship cassette deck, and the spec sheet reads like it belongs to a machine twice its price. 3 heads, 3 motors, a dual capstan closed-loop tape path, dual Dolby circuits, servo-controlled winding, remote control capability, and an editing facility lifted straight from professional open-reel machines. Tandberg's own literature claimed the TCD 330 compared favorably with open-reel decks of the same era, and the reviewers who actually tested it largely agreed. This was a cassette deck performing at a level the format was never designed to reach. Here is the part that makes the story sting. Tandberg had actually been the first company in the world to put a 3-motor, dual capstan closed-loop system into a cassette deck, starting with the TCD 300 back in 1972, years before most Japanese competitors caught up. The 330 was the refinement of that head start. The deck even came in a real wood case, teak or rosewood as standard, oak or walnut on special order. It was delivered like furniture, not like disposable electronics. But the Japanese giants eventually overwhelmed Tandberg on price and volume. By the early 1980s, a small Norwegian firm that had genuinely beaten the establishment on pure engineering was cornered and priced out of existence. The best engineering does not always win. Sometimes it simply gets outspent. Tandberg proved that a tiny company from Scandinavia could build a cassette deck that matched or beat anything coming out of Japan. And then the market shrugged and bought the cheaper option anyway. If that does not make you question how you shop for gear, nothing will. Everything on this list so far was chasing one target. The machine at number 1 is the target itself, the deck that started the entire 3-head revolution and became the most revered cassette deck ever built. Number 1, the Nakamichi 1000. In 1973, the very idea of a reference-grade cassette deck was considered absurd. Reel-to-reel was the serious format. Cassette was for convenience and nothing more. Nakamichi looked at that consensus and simply ignored it. The Model 1000 Tri-Tracer was the world's first 3-head cassette deck. 3 completely separate heads, erase, record, and playback, each optimized for its single task, extending flat frequency response beyond 20,000 Hz on a format that most engineers assumed topped out well below that. The playback head used a gap so narrow it pushed the absolute limits of what precision manufacturing could achieve at the time. Before the 1000, Nakamichi had been a quiet OEM builder, making tape decks behind the scenes for Harman Kardon, Fisher, KLH, Advent, and others under their badges. Nobody outside the industry knew the name. The 1000 was the moment Nakamichi stepped out from behind the curtain and put its own name on the front panel. And the industry never looked at cassette the same way again. The machine weighed nearly 18 kilograms, close to 40 pounds. It offered 5-channel, 3-way mixing and its own dedicated remote control. The later 1000 ZXL generation added a computer system called Able that automatically optimized azimuth, bias, level, and equalization for whatever specific tape you loaded. The Nakamichi 1000 stayed in production in various forms from 1973 all the way to 1984. More than a decade as the benchmark every other serious deck was measured against. The Nakamichi 1000 did what great engineering always does. It made the experts wrong. The format was supposed to be a toy. This machine made it a reference standard. It did not win by marketing. It did not win by being cheap. It won by being so relentlessly, obsessively good that the rest of the industry had no choice but to follow. Nobody builds like that anymore because nobody is willing to be that stubborn about quality when a cheaper shortcut exists. These 5 machines fought a format's own physical limitations and won. They were not built to be replaced in 18 months. They were built to be repaired, kept, and handed down. Some of the companies that made them no longer exist. The machines still do. That tells you everything about what matters in the things you buy. Real engineering outlives the spreadsheet that says it should not exist.